So we've learned how to solve systems of linear inequalities by looking for overlapping solution regions. Well, let's use it in our life. And what better way to use math in our lives than with Girl Scout cookies? Danielle sells cookies during Girl Scout cookie season. Excellent. Her troop only sells Caramel Delights and Thin Mints, and that's okay because those are the two most delicious flavors. Absolutely. Caramel Delights are $3 per box, and Thin Mints are $2 per box. Danielle has goals. She sets the following sales goals for this season. She wants to sell more Caramel Delights than Thin Mints because they're more expensive, so she'll get a higher profit on them. Number 2, she wants to sell more than $60 worth of product overall. Those are her two goals. Those are great goals. Very business-minded, Danielle is. If Danielle's troop only sells Caramel Delights and Thin Mints, how many Caramel Delights and Thin Mints would set her sales goals? So let's think about this for a moment. We don't know how many Caramel Delights she's going to sell. So let's say X is Caramel Delights. That would make Y Thin Mints. Those are two pieces of the puzzle that we've already pulled out from the problem. Now, if you'll remember, she wanted to sell $60 or more, at least $60 total or more. And she also wanted to sell more Caramel Delights than Thin Mints. So let's think about this. Well, Caramel Delights cost $3. Thin Mints cost $2. Now we have all the pieces of our puzzle. So thinking about this, well, let's be consistent and put our dollars with dollars with dollars. So $3 is the cost of Caramel Delights. That's 3x. And she also earns money by selling Thin Mints for $2 plus 2y. Now, she wants to sell more than $60 worth of total product. More than $60 worth of total product. Okay. So there we go. We've got a linear inequality right there. And it's delicious looking because it represents Caramel Delights and Thin Mints. Now she also wants to sell more Caramel Delights than Thin Mints. Well, if Caramel Delights are X and Thin Mints are Y, she wants to sell more Caramel Delights than Thin Mints. So X is greater than Y. Now this is not solved for Y. We can't graph this yet. But let's go ahead and give it a shot. The first thing that we'll do is we'll need to isolate Y. And to do that, we'll need to eliminate X. So we will subtract 3x from both sides. That will leave us with 2y is greater than 60 minus 3x. Now what we'll do is divide both sides by 2 to isolate for y. We have to be fair and make sure we divide everything by 2. Now the 2 cancels out, and we're left with y is greater than 30 minus 3x over 2. Okay. And then on the other side, well, if we just reverse this and put it the other way around, y is less than x. Y is less than x. Okay. Well, now we have our two linear inequalities, and we can graph them and see where the overlapping solution region is. Let's give that a shot. Now we have our coordinate grid here, and let's just draw some axes in here. I'm going to disappear for a moment as I draw this other axis. Don't worry, I'll come right back. Okay. Now, our y-intercept is 30. But you're going to be able to see here that this graph does not go all the way to 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It doesn't go all the way to 30. So instead, why don't we do something which is called scaling our graph? Instead of each box representing 1 unit, oh no, why don't we have every box representing 3 units? So it would be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And that's okay as long as we write that. 3, and we don't have to do everyone. 3, 6, 9, 12, 15, 18, 21. And this will help us graph this problem a little easier. Okay. Now, our slope is negative 3x over 2, meaning we need to go down 1, 2, 3, and over 1, 2. So we'll go down 1, 2, 3, and over 1, 2. Down 1, 2, 3, and over 1, 2. And down 1, 2, 3, and over 1, 2. So now we have graphed this entire line. And the reason we're able to use the same exact slope is because if we scale this y-axis, well, in order to use the same slope, we need to scale the x-axis by the same amount. So this will also be 3, 6, 9, 12, 15, 18, 21, 24. Okay. So as long as you scale the x and y axis by the same exact amount, you can still do the same slope, down 3 over 2, down 3 over 2. The line will look the exact same. So, now we can draw, do we draw a straight line through this or a dotted line? Well, it's y is greater than, so it will be a dotted line. Okay, and the solution region is out here because y is greater than. Okay. Now, we draw the second line, which is y is less than x. Well, the y-intercept there is 0, because y is less than x plus 0. So the y-intercept is 0. And then the slope is 1, because the coefficient on x is 1. So we go up 1 over 1, 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 and so on. Okay. Now y is less than x, so we have to shade downward. Shading downward. So as we can see, the overlapping solution region is going to be in this area over here. So any coordinate in this solution region will be true. Let's just pick, for example, this point right here. Well, since we scaled the graph, let's determine what that point is. 24, 27, 30, 33. Okay, so this is an x value of 33. And this is a y value of 21. Now let's go back over to the board and make sure that this fulfilled both of Danielle's requirements. This was 33, 21. Well, the x represents Caramel Delights. So if this is 33, the y represents Thin Mints. 21 is less than 33. That makes sense. She sold more Caramel Delights because they had a higher profit margins and she was thinking about making more money. Now let's see if it works on this particular example. Y is greater than 30 minus 3x over 2. Well, we input 33 for x and 21 for y. Three times 33 over 2. Let me make a little bit more space here. Well, 21 is greater than 30 minus 3 times 33. That's 99. 99 divided by 2. Well, as you can see, this is going to end up being true, and we don't even need to complete the calculation. 21 will be bigger than 30 minus 99 over 2. Let's estimate. 99 is almost 100. 100 divided by 2 is 50. 30 minus 50 is a negative number. So 21 will be bigger than that negative number. We checked the solution point within the solution region, and it worked. So to summarize, in order to solve problems with linear inequalities in your life, simply pick out the puzzle pieces as you did before, graph the linear inequalities, and if necessary, scale your graph so you can fit the data on your coordinate plane, and then determine where the overlapping solution regions are. Thank you, and have a great day.